This is Unit 4, Lesson 2, Part 2. So we're talking about all the different ways that we can represent quadratic equations. So there is the standard form, vertex form, factored form, and then what the graph looks like. So in each one of these, you're going to get one out of those four and then fill in the blanks for the rest. So we're going to try one of each type. So we're going to do this very first one here where you are given the standard form. So the first thing that you have to do when you are given standard form is convert it from standard form into vertex form. Okay, so we'll get a reminder of how that works. So we start with, remember you just group these two together first. Like that's the very first thing, is just kind of separate out, here's my quadratic part, here's my linear part, just literally to separate it from that constant piece that you have. Then, if there was something in front of the x squared, you would have to take that out next, but since this is just a 1x squared, you don't have to do that step. So after this, you take your middle term, your b, whatever that number is, you cut it in half, that gives us -4, and then you take that -4 and you square it, and that gives us 16. So the 16 is the number that we say completes the square, so we're gonna put it in the parentheses with that binomial that we have so far. So we have x squared minus 8x plus 16, close the parentheses, and then we still had the plus 15 right here, and then to finish this off, we have to balance out what we just added in. So we just added the 16. Since we're staying on the same side of the equation, what we're gonna do is add it and then immediately subtract it. So add 16 and then subtract 16. Sorry, run it into that other box a little bit. Then we factor, simplify, and that's it. So this factors down, we're looking for what multiplies to 16 and adds to a -8. So this would be x minus 4, or x minus 4 squared. That's why we call it completing the square, because we can write it like that. And then 15 minus 16, we have -1 at the end. So that is our vertex form. We're gonna write down just a couple details to help us graph. So the vertex is, remember, the opposite of this, so +4, and then this number, -1. And our axis of symmetry just goes right through the vertex. It shares the same x value. So that is x equals 4. Like I said, that'll help us when we're graphing. All right, so in the factored form, super easy. If we're given this form, we just take it and we factor it down. All right, so this, we are looking for two values that multiply to 15 and combine up to a -8. So we know we start with x and x because this is just an x squared. So multiplying to 15 and adding to -8 would be -5 and -3. And then remember what our factored form gives us is the roots, or the x-intercepts. So our roots, we have x equals, this one, if I set that equal to 0, it gives me 5. And this one, if I set it equal to 0, it gives me 3. Okay, so I'm gonna combine this information with this information to put it together on our graph. All right, so I'm gonna start with my vertex, 4, -1, so I go 1, 2, 3, 4, down to -1, so that's my turning point. My axis of symmetry, we know, runs right through this part right here, and then my roots are at 5, so 5 on the x-axis is right here, and 3 on the x-axis is right here. So 3 points is generally enough to graph the shape of the parabola. So we just connect the dots, and that is what our graph looks like. Okay, so that's the first type where you're given the standard form. You have to fill out everything else. We are actually gonna look at the next page, and we're gonna do the top one where you're given that vertex form, and then you have to figure out everything else. So first thing we're gonna wanna do is go from vertex form into standard form. So that involves, you know, some foiling, some distributing. So let's get started. Follow the order of operations. So first thing we're gonna do is take care of this exponent. We can't do anything inside the parentheses because you can't do anything with x minus 1. So we square this, which means we are going to write it out twice and FOIL it, and then +3. So just leave this here for the time being. This -3 just stays right there. I'm gonna FOIL this out, so I do x times x, which is x squared, minus 1x minus 1x, so my outside and inside, I have minus x, so that would be a -2x, and my last, -1 times -1 is +1, and then I add 3 right here. So then, multiplication, we're gonna take this -3 and distribute. So distribute, I have negative 3x squared plus 6x minus 3. And then after the parentheses, I still have this plus 3. And last thing to do is just combine like terms. I just have this plus 3 minus 3 to add together. And when I do that, they actually cancel. So I have negative 3x squared plus 6x, and that's it. That is our standard form of this equation. So I take that and I can factor that over here. So this one, I only have 2 terms, but it's not the difference of squares, so that must mean that there's a GCF. So I'm going to take out my GCF. I'm going to take out a negative 3x. That's what they both have in common. So take out a negative 3x, leave my leftovers in parentheses, and without that, this will leave behind an x. This will leave behind a negative 2. So that's my factored form. And remember what that tells me is what my roots are. So I set each piece equal to 0. If I set this piece equal to 0, I just divide by negative 3. That leaves me with 0. If I set this piece equal to 0, I add 2. It gives me 2. So I'm going to do my graph. I'll start with these roots. So I have x-intercepts at 0 and at 2. And then if we go back to this is going to tell me my vertex. So I know my vertex is positive 1 for x, and then positive 3 for y. And then I use that for my axis of symmetry. I do x equals, share the same x value, it's 1. So I can plot all that. So my vertex is 1, 3, so over 1, up 3 is this point right here. And my axis of symmetry runs right through that vertex. So again, 3 points is enough, just connect the dots. You can see the shape of that parabola. It's upside down and it's stretched a little bit because of this negative 3 right here. The negative flips it and the 3 stretches it. All right, we are going to do one more. We're going to do the one right below it where you're given factored form and you have to figure out everything else. So factored form into standard form is pretty straightforward. We're just going to FOIL. So I'm going to FOIL this out. So x times x gives me x squared. Outside, x times 7. Inside, 3 times x. And last, 3 times 7. So that is just one more step remaining. I need to combine these up. Then it will be my standard form. So x squared, combine these up to a 10x, and this is a 21. That is my standard form. I'm gonna box this up too. All right, so now the vertex form, I do what I did on that front page. I can go from my standard form into my vertex form by doing that, completing the square process. So let's write that down. So first thing I do is literally just isolate these 2 terms from the last term. Then, if there was something here to factor out, I would do it, but there isn't. So then I go to this 10, I cut it in half, that gives me 5. Take that 5 and square it, that gives me 25. So that's what I add inside the parentheses. So I have x squared plus 10x plus 25. Add that right inside the parentheses. And then I had this plus 21 outside, but because I added this 25, I have to balance it by subtracting 25. Make sure I'm not actually changing my equation. So factor the parentheses. We're looking for what multiplies to 25 and adds to 10, and that would be 5 and 5. So I could write x plus 5, otherwise known as x plus 5 squared. Combine these up, I get a minus 4 at the end, and that is my vertex form. So here's the form itself, and then what it tells me. My vertex, remember x is the opposite, so this is a negative 5, and then the same for y, so negative 4. And I can get my axis of symmetry. It just shares that same x value. So it's negative 5. So let's plot that. Negative 5, 1, 2, 3, 4, 5, and negative 4. And I know the axis runs right down the middle here. And I also can use this to get my roots. So set this first one equal to 0, I get negative 3. Set this second one equal to 0, I get negative 7. So I can plot those on the x-axis. So negative 3 on the x-axis, 1, 2, 3, and negative 7. We knew this was negative 5, negative 6, negative 7. So 3 points for my parabola. Go ahead and connect the dots, and that is our third and final graph.